In this video, I'm going to run through electromagnets. To understand electromagnets, we first must understand what a force on a current carrying wire is. So if we pass current through a wire, as shown in this diagram here, what we get is a magnetic field going around the wire. The direction of the magnetic field going around the wire can be determined using the right hand grip rule, as shown here. So the current will flow through here. Use your right hand in a grip, and the direction of your fingers pointing in the direction of the magnetic field, as shown like this. So when a current flows around a conducting wire, a magnetic field is produced around the wire. That is because a moving charge generates its own magnetic field. The size of the magnetic field depends on two things: the size of the current through the wire, so the faster the current or the more current, the greater the magnetic field, and also the distance you move away from the wire. Just like with a real magnet, the further the distance from the magnet, or in this case the wire, the less the magnetic field strength. If a current carrying conductor or wire is placed in a magnetic field, it will experience a force, and this force will cause the wire or conductor to move. So if you take a wire and wrap it around into a coil, which we now call a solenoid, we can change the way the magnetic field works. So a solenoid is a straight coil of wire which can be used to create a strong magnetic field when the current travels through the wire. So rather than just moving in a straight line, you can see that we've wrapped the wire around, which means that the current is flowing around in a circle. So rather than having a magnetic field that goes around the wire, we now have a magnetic field that goes through the solenoid. So if we were to look at this bit here, we can see at this side we'd end up with a north, as I've shown there. So there's a north. And at this side, we'd end up with a south pole. And there's a south. And what that basically means is that we've generated a magnetic field around an electric coil. The magnetic field in the solenoid is strong and uniform, and it's very similar to that that's produced by a bar magnet. Now if we were to add an iron core, so basically put a piece of iron inside the solenoid and wrap the solenoid around the iron core, we basically create an electromagnet, because the magnetic field that is generated by the current goes into the iron core, and the iron core becomes magnetised, and therefore that enhances the magnetic field. So we've got an electromagnet. We can then use that then in order to pick things up like paper clips. So how we would do that is we have the electromagnet here, so you've got the solenoid wrapped around the iron core. We can then close this switch, and as we close the switch we complete a circuit. That allows the current to flow, and the current will flow around the wire which is in the solenoid. The flowing current produces a magnetic field around the coil, which causes a magnetic field to be induced in terms of the iron core. It makes the iron core become magnetised. So what we can then do, once this is magnetised, we can move that near a paper clip, and it will pick the paper clip up, and we can test the strength of it by hanging multiple paper clips on there. And if we want the electromagnet to drop the paper clip, all we need to do is reopen the switch, and the electromagnet will lose its magnetism, and the paper clips will then fall because they're induced magnets.